All right, this is the 6, 4, 6, 5, 6, 6 review. All right, so for 1 through 13 here, we're going to determine if these quadrilaterals are parallelograms. If they are, we're going to explain why. If they're not, we're going to give an additional piece of information that would make them a parallelogram. Okay, so to show that a quadrilateral is a parallelogram, we have these 5 ways here. So the first thing we have, though, is the definition of a parallelogram. A parallelogram is a quadrilateral that has 2 pairs of opposite sides that are parallel. That is the definition. So 2 pairs of opposite sides parallel. So that's one way, right? If it is a parallelogram, by definition, it's a parallelogram, right? But then we have these 5 additional ways. 1, 2, 3, 4, and 5, right? The 5 additional ways. Okay, so that's what we're going to be looking at to do these 13 questions. All right, number 1, is this a parallelogram? Yes, it's a parallelogram because the definition of a parallelogram, it has 2 pairs of opposite sides that are parallel, and that's what those arrows indicate. So we have 2 pair of opposite sides that are parallel. And again, that's not one of the 5 properties listed here, or the 5 ways listed here, because that's just simply the definition of a parallelogram. That's what a parallelogram is. If it has 2 pair quadrilateral with 2 pairs of opposite sides that are parallel, it is a parallelogram. That's the definition of a parallelogram. All right, number 2 here, will this always form a parallelogram? No. We need 2 pairs of opposite sides that are parallel. So what additional information can we add? We could add is if DQ was parallel to AU, right? Then we would have a parallelogram. Okay. You could also say AD is congruent to UQ, right? That would give you a parallelogram as well from that second property. 1 pair of opposite sides is congruent and parallel, but this one's fine. All right, 3 through 6 here. Will this always be a parallelogram? We're going to say no. Okay. We need to have 2 pairs of opposite sides that are congruent. So I'm going to add in the other pair. DQ is congruent to AU. If those 2 opposite sides are equal, right, and those segments are congruent, then it's going to be a parallelogram because you would have 2 pairs of opposite sides that were congruent. Number 4, we're going to say yes, because we already do have 2 pairs of opposite sides that are congruent. So this one is 2 pairs of opposite sides are congruent. All right. Number 5, we have alternate interior angles here. We know if alternate interior angles are congruent, the lines are parallel. So we know that DQ is going to be parallel to AU. But that's not going to be enough. We're going to either need a second pair of parallel sides. So for example, if AD was parallel to UQ, right? We could do that. AD parallel to UQ. Then we'd have enough information to say this was a parallelogram. Okay, but those alternate interior angles tell us that DQ is parallel to AU. But same thing with angle QDU and angle AUD, right? It still gives us just the left and the right sides parallel. We would also need the top and the bottom to be parallel. All right, number 6 is going to be a yes. Okay, we're looking at this one right here. One angle is supplementary to both consecutive angles. So again, this looks just like what it is on the property sheet for us. Right, so one angle, right, angle Q is supplementary with both consecutive angles. Angles, not angels. Yep, these add up to 180, right? 180 minus x. So if this was 60, 180 minus 60 is 120. And if this is 60, u is 60. 180 minus 60, 120. So angle Q is supplementary with both angles. All right, 7 and 8. So I'm gonna say no here, right? We have one pair of opposite angles that's congruent and one pair of opposite angles that are parallel, but they need to be the same pair of opposite angles that's congruent and parallel. So if I look real quick at my diagram, right, it needs to be one pair of opposite sides is congruent and parallel. It needs to be the same set of sides that's congruent and parallel. So I could add, if AD was congruent to UG, then we'd have a parallelogram. You'd have two pair of opposite sides congruent. You'd have one pair of opposite sides congruent and parallel, right? Lots of different things we could add to make this a parallelogram. Okay, and then this one's going to be yes for that same reason, right? You have one pair of opposite sides that is congruent and parallel, right? It's the same pair of opposite sides. It's congruent and parallel. All right, 9 and 10. No, we need two pairs of opposite angles to be congruent, right? Two pairs of opposite angles. So I would also need angle Q to be congruent to angle A. All right, and then this one would be a yes for that same reason. Two pairs of opposite angles are congruent. All right, pretty straightforward. All right, and then 11 and 12. So again, if you look at 12, diagonals bisect each other. So again, that looks just like this one right here. The diagonals bisect each other, so the quadrilateral is a parallelogram. Over here, though, right, we would need to add a second pair of, I'm sorry, not a second pair of sides, but the other diagonal getting bisected. In number 11, only one diagonal, AQ, gets bisected. We would need UD to also be getting bisected. So segment Yep. Okay, and then this one would be two diagonals bisect each other. Yep. All right. Last two here. Is this always going to be a parallelogram? The answer is no. Right? We need opposite sides. Needs to be opposite sides that are congruent, right? Not consecutive sides. So if again, if we look at the property sheet, right, it clearly says right here, two pairs of opposite angles. I'm sorry, opposite sides right here. Pairs of opposite sides. All right, if this is a parallelogram, we know opposite sides are congruent. So DQ is congruent to AU, DA is congruent to UQ. And then by the reflexive property, AQ would be congruent to AQ. So then to show that these two triangles, triangle QDA is congruent to triangle AUQ, we're going to use side, 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 right? We have three pairs of congruent sides. It means the triangles are congruent by side, side, side. All right, on to 15 here. Am I able to zoom out a little bit? That's what I was trying to move. There we go. All right, angle BAD. That's this angle right here, BAD. Right? This angle is 64 degrees. 64 degrees. Okay, since this is a rhombus and diagonals bisect opposite angles, right? Here's our rhombus. Diagonals bisect opposite angles. We know that each of those individually is going to be 32 degrees. Half of 64 is 32. Okay, and then the ones across, since opposite angles are congruent in a parallelogram, we're going to have 32 and 32. So the measure of angle ECD, this angle right here, is 32 degrees. Right, the big one's 64. Each one individually is 32. All right, EDC. So let's look at EDC. That's the small one here, right? That little small one right here is 43 degrees. Since this is a rhombus and the diagonals bisect opposite angles, the one next to it is also 43, which means the ones across are 43 and 43. And this one's asking us for CBA. So CBA, which is going to be the entire big angle, which is 43 plus 43, which gives me 86 degrees. 86 degrees. All right, angle BEC, this one right here, that should be 90 because the diagonals of a rhombus are perpendicular. Okay, so this diagram isn't quite to scale, but since it says it's a rhombus, we know the diagonals are perpendicular, so that's a right angle. So we know that 3x minus 15 equals 90 degrees. If we add 15 to both sides, we're going to get 3x equals 105. And then we divide both sides by 3, we're going to get x equals 90 would be 30. So that's 15, 5, and 30 is 35. All right, x equals 35. All right, D down here, I got to scroll down a bit. Okay, angle ADE, that's this one right here, where it's going to be 5x minus 8. And angle CBE is going to be 3x plus 24. Okay, in a rhombus, remember all 4 of these smaller angles here are going to be equal to each other. So we can set 5x minus 8 equal to 3x plus 24. And we can solve for x. So that's going to be 2x. We subtract 3x from both sides. We add 8 to both sides. We divide by 2 on both sides. And we get x equals 16. All right, the last one down here. Let's look. Okay. So angle BAD, again, that's the big one here. And then angle, well, let me fill it in. So BAD is 4x plus 14. To green. Okay, and then angle ABC, which is this angle right here. It's going to be 2x plus 10. Right, if you're using just a normal looking parallelogram, right, we're talking about these 2 angles right here. Those are consecutive angles, which means they have to add up to 180. So on this one, we're doing 4x plus 14 plus 2x plus 10 equals 180. So that's going to give me 6x plus 24 equals 180 when I combine like terms. When I subtract 24 from both sides, I get 6x equals 154. And then when I divide both sides by 6, I'm going to get x equals 26. That's for the last one. All right, let's move to the back. So given quadrilateral FISH is a square, and FI is 2 centimeters. So FI here is 2 centimeters. Since it's a square, that means all of the sides are going to be 2 centimeters, right? Which means IS is going to equal 2 centimeters. All right, now we got to find the angle. Since it's a square, we know that all 4 angles are right angles. And since it's a rhombus, the diagonals bisect those angles. So all of those little ones here are going to be 45 degrees. Right? All of these little ones are 45 degrees. And then in the middle, since it's a rhombus, diagonals are perpendicular, right? A square is a rectangle and a rhombus. So those are all 90. So the measure of angle FYI is going to be 90 degrees. The measure of angle HSF is going to be 45 degrees. That's a square, which is a rectangle and a rhombus. Number 17 here is just a rhombus. Okay, let's do the sides first and then the angles. So BH is what we're solving for first. It says RH is 15. RB is 9. All right, so we're going to look at this triangle. It's a right triangle. We know it's a right triangle because this is a rhombus. And in a rhombus, the diagonals are perpendicular. So this triangle is a right triangle. So we're going to call this X, and we're going to use the Pythagorean theorem. We're going to do A squared plus B squared equals C squared. The C here is 15 because 15 is across from the right angle. So X squared plus 9 squared or 9 squared plus X squared was 15 squared. So we get X squared plus 81 equals to 25. We subtract 81 from both sides, we get 144. And then when you take the square root of both sides to get rid of the square, you get X equals 12, plus or minus 12, but we're not going to use the negative one. So this is going to be 12, which means MB is also 12 and BO is also 9, and then 15, 15, 15. All right, we're just looking for RO though. That's going to be 9 plus 9, which is 18. All right, those are sides. Let's do angles. I'm going to do angles in blue. So it's a rhombus, so diagonals bisect opposite angles. So if that one's 53, the one next to it is also 53. And then across, you're going to have 53 and 53. All right, the 4 angles in the middle should all be 90. And then the 3 angles of a triangle add up to 180. So 180 minus 90 minus 53 gives me 37. So all of these angles here are going to be 37. All right, we are looking for angle RBH right there. So that one is going to be 90 degrees. All right, the next one, MOH. So that's the big angle there, right? MOH, that's going to be 53 plus 53, which is 106 degrees. Okay, and then the last one here, RMB. RMB, right? This angle right here is going to be 37. All right, next one is a rectangle. So that was the rhombus, now the rectangle. We know a rectangle has 4 right angles. Here, we can do alternate interior angles. So this is 12.68 degrees, right? If we wanted to filter the other ones out, we could put 90, 90, and then 90 minus 12.68, which is going to be 77.32. Let me put it in my calculator just to make sure. Yeah. And 77.32, right? But we're looking for this one here. Angle AOGA. All right, let's do sides now. Okay. So it says that the perimeter is 98, GL is 9, which means OG is also 9. Right? If we make LAX, that means GAO is also X. So perimeter is when you add all the sides together. So if we do 2X plus 9 plus 9, right? Or we could just start by saying this is X plus X plus 9 equals the total perimeter, which is 98. So that's 2X plus 18. You subtract 18 from both sides, we get 2X equals 80, and you get X equals 40. Right, and then we're going to use a triangle, right triangle. So we're going to end up using the Pythagorean theorem. So let me highlight the triangle we're going to use. This triangle right here. It doesn't matter, actually, it could be either one. And we're going to do a squared plus b squared equals c squared. So y here is across from the right angle, so that's your hypotenuse. So we're going to do 9 squared plus 40 squared equals c squared. That's going to give me 81 plus 1600, which gives me 1681 equals c squared. And when you take the square to both sides, you get 41 equals c. So GA there is 41 units, or yards, I should say. And then GO was 40 yards. All right. Last half page here. Okay. Rectangles, rhombuses, squares are all types of parallelograms or quadrilaterals or polygons, right? There's a number of different answers you could be put here. And thus they have all the characteristics of polygons, quadrilaterals, and parallelograms. Okay. If a quadrilateral is a rhombus, then the diagonal should be perpendicular. Right? If a quadrilateral is a rhombus, then the diagonals bisect opposite angles. If it's a rectangle, then the diagonals are going to be congruent. Congruent, not congruent. Congruent. Okay, and then a square is both a rectangle and a rhombus and a parallelogram. Therefore, it has all the characteristics of all those. And we can see all that on our property sheet here. Right, I can zoom out a little, right? You got all these are quadrilaterals. Here's your parallelograms. You notice in the parallelogram circle, you have rectangles, rhombus, and squares, right? So all of these have properties of parallelograms. Rectangles, there's your diagonals are congruent. There's your rhombus, diagonals are perpendicular and bisect opposite angles. And then there's square in the middle. It has the properties of rectangles because it's a rectangle. It has properties of a rhombus because it's a rhombus. And it has properties of a parallelogram because it's a parallelogram. All right, let's answer some of the questions then down here on number 20. Okay, so for number 20, this is the start of 6-6. So what we want to be looking at here are these, right? So in order to be a rhombus, rectangle, or square, we basically are looking for their properties and working backwards. So if you have a parallelogram, it's going to be a rhombus if the diagonals are perpendicular, or if the diagonals bisect opposite angles. It's going to be a rectangle if the diagonals are congruent, and it will be a square if it's a combination of the two. So diagonals are perpendicular and congruent, or diagonals bisect opposite angles and are congruent. All right, so on the first one here, I notice a right angle. That means my diagonals are perpendicular. So this is going to be a rhombus because diagonals are perpendicular. Diagonals are... Yep. All right, on this one, again, I notice right angles, which means this is a rhombus because diagonals are perpendicular. But I also notice that the diagonals are congruent. So this is going to be a square because it's a rhombus because diagonals are perpendicular, and it's a rectangle because diagonals are congruent. Therefore, it's both a rectangle and a rhombus, which means the best description is a square. Diagonals are congruent and perpendicular. All right, number or C, 20C here is just going to be a regular old parallelogram. Right, none of our conditions fit. Right, none of these conditions on this page fit, so it's just going to be a regular old parallelogram. No, not a special parallelogram. All right, the next one is a rhombus because the diagonals bisect those opposite angles, right? Oops. So if we're looking right here, diagonal bisects angles. So you just need one diagonal to bisect the opposite angles. And there we go. All right, and now we got a few questions where you got to draw out the diagrams. So we're just drawing them out here. A, B, C, D is a rectangle. So A, B, C, and D. So then my two things they're giving me, expressions they're giving me here are for the diagonals, AC and BD. Well, if we know if it's a rectangle, the diagonals are going to be congruent. So we can set them equal to each other. 4x minus 5 equals 3x minus 1. You subtract 3x from both sides, you get x minus 5 equals negative 1. You add 5 to both sides, you get x equals 4. All right, for the rhombus over here, let me draw it out, right? We have E, F, G, and H. Okay, angle EF, I'm sorry, EFGH. So angle EFH, right? So let me draw that in. That's this angle right here. Whoops, let me do a different color. EFH. That's this one right here. Right? Is going to be 3x minus 15, and then GFH. That's this one right here. Is going to be 2x plus 9. So in a rhombus, the diagonals bisect the opposite angles. This big angle in blue here, EFG, is getting split in half, and then the red and the green are going to be equal to each other. So what we're going to do here is we're going to set these equal to each other. So we're going to do 3x minus 15 equals 2x plus 9. We're going to subtract 2x on both sides. We're going to add 15 to both sides, and we get x equals 24. Yep. All right, next one, rectangle ABCD. A, B, C, D. Okay, so again, AC and BD are your diagonals. So we're going to set them equal to each other. So 4B plus 2 equals 6B minus 2. All right, we're going to subtract 4B on both sides and get 2B minus 2. We're going to add 2 on both sides. And we get 2 equals B. And then when we substitute that in, we're finding the length of AC. That's the whole diagonal. So 6 times 2 minus 2 gives us 10. All right, last one. All right, I'm going to draw this one up here just so we have room. So A, B, C, D. All right, the length of AD is 6. And the length of AC is 3x minus 15. And the length of BD is x plus 5. So those are the diagonals again. So we're going to set them equal to each other. So 3x minus 5 equals x plus 5. Subtract x on both sides. Add 5 to both sides. And then divide by 2, you get x equals 5. All right, so my diagonal here is 10 if you plug it in, right? 3 times 5, 15 minus 5 is 10. And we need to find CD, right? So we can find the perimeter of this. So again, if you're looking at the triangle, this is the triangle we're looking at. This is X, 10, and 6. So what we're going to do is a squared plus b squared equals c squared. So x squared plus 36 equals 100. When you subtract 36 from both sides, you get 64. And then you get x equals plus or minus 8, but we don't want the minus, so we just want the 8. Right? So then this is going to be 8. AB's 8 and 6. So we're going to do 6 plus 8 plus 6 plus 8, which gives us a total of 28 for our perimeter. And that is the review.